Hey everybody, we're going to go through the last module in this class, which is charging. So your last lab is kind of going to be a combination lab. So on that last lab, you're actually going to do 3 modules worth of work in the lab. So you're going to cover recovery. You're also going to cover vacuum and pump down. So we're going to learn how to pump refrigerant out of the line set and into the outdoor unit, how to pump the system down, and then how to recharge. So kind of going to do all that in one. So last time we left off, we talked about vacuum and we talked about recovering refrigerant. So now we're going to learn how to put refrigerant back in. So there's a couple of different ways that you can do this. And so in your lab 6B, when we did that lab, we actually charged refrigerant in to a system that already had refrigerant in it. We just added some to it. So a couple of different ways to charge. One is from a system that's already got refrigerant, and the other one would be from an empty system. So get my PowerPoint to cooperate here. All right, so if you're charging a system with refrigerant already in it, then you're going to actually start that system from start it running in cooling, and you're going to run it just like you normally would. Gauge is hooked up just like you always would, and then your yellow hose is going to be connected to your external tank. So your charging tank, or if you're charging from a recovery cylinder, I guess you could do that as well. So with the compressor running, you're going to want to add it. You have to add it in unless it's R22, and even if it is R22, you can do it as a liquid as well. So I don't really even recommend that anybody do any vapor charging anymore. Several years ago, that's what everybody did on 22. But now that since most of our refrigerants are blended, you're going to have to put those in as a liquid. So you dump those in as a liquid because they are a blend of other refrigerants that make up that blend. 22 was the only one that we really used. 134A, I think, might be too, but that you can put in as a vapor. But you can put those in as a liquid too. Once you learn how to do it, it's quicker. It's a better way anyway, in my opinion. So the main thing you got to watch is that you don't do what you call sludging the compressor to where you're actually dumping liquid in right on top of the compressor. So in this example, you can actually see that this is a different type of compressor than what we're using in class on our residential systems. This is a hermetic reciprocating compressor. Sorry. So with this one, it would be really easy to damage it because you could dump liquid right in on top of that piston. So you really got to watch what you're doing. Most of the ones that we're working on, just residential split systems, they are a little more forgiving than this one would be, but you've still got to really watch about dumping liquid. So the first thing you're going to do is you're going to run the compressor, just like always. And then you're going to access your low side pressures on your low side gauge. Then you're going to open that low side valve and charge it by a liquid. And so what you want to do is you want to charge it until your condensing temperature gets to the right temperature above ambient. So let me see if I get a different view here. Okay, so your outdoor plus 20 or whatever it is that you're shooting for, that'd be a good way to tell because you're measuring condensing pressures because you're not messing up the high side. It's just reading pressure. So that would be a good indication. Once you get it to outdoor plus 20 or whatever you're going for, in that case, that'd be a good place to stop and kind of check everything. So you want to go pretty slow with it because you don't want to flood back liquid. You don't want to flood your compressor, and you don't want to add too much too quick. And then by the time everything kind of catches up, you end up overcharged. So you want to do this fairly slow. Listen, it says monitor compressor amps. That wouldn't be a bad idea. If it starts, getting too much liquid, it's going to make your amperage go up. And honestly, you can tell a lot by the sound of the compressor. If the compressor starts making a lot of noise, you start hearing things chattering and maybe running rougher than they normally do. That may be a sign that you need to back off. I always recommend that when you're putting in liquid that you meter it through your gauges. So they don't really say to do that here, but that's definitely what I recommend to do. So as you're putting that liquid in, you want to meter it through your manifold gauge, through your suction gauge, which means just barely opening that up until you start seeing that needle fluctuate. Once that needle starts to fluctuate, you'll have this on a scale. Scale is very important because if you don't have it on a scale, it's really hard to tell how much you're putting in, which is hard to tell how much to charge the customer, for one thing. But then it's just, you're adding a very small amount at a time. And so you may think you're not adding or you're not adding enough, but the scale will verify that you are. So that's something that you're going to want to pay attention to, is your scales as well. So if you're adding a few ounces, it's going to go in pretty slow, but it's not going to take very long still to add just a few ounces. All right, so if system's running, you're going to do it that way. So that's kind of topping off a system. System's a little bit low, whatever. You got to add some charge for whatever reason. Now, what if the system is empty? All right, so a couple of different, and I'm going to use this as a guide, but I may not go step by step through this. So if your system's completely empty, if it's been open to atmosphere, which means it's been open, to outside air whatsoever, you have to pull a vacuum. Now, if you just recovered refrigerant and you're able to keep everything hooked up and everything isolated, and you just pull the refrigerant out into a recovery cylinder and you're going to go right back in with it, you won't have to pull a vacuum on that. So that may save you a bunch of time on pulling a vacuum if you've got to do that. So in order to do that, you really have to make sure that you kept all your valves closed when they're supposed to be, and you're not exposing that at any point. So if you have to pull a system down to a vacuum, you're going to run it down to your micron readings, 500 or below, and do your decay test and all the things that that we've learned how to do, or that we're learning how to do. And then you're going to add that back in to the system that's off. So if the system has, and it says refrigerant capacity over 5 pounds, I don't know exactly where they're getting that number at, but needs to be clean in a vacuum or not exposed to atmosphere. The compressor would be off. That's critical, because what we're going to do on this way, if we're charging it from flat to where the pressure of the tank is actually higher than the system pressure, you can dump it into the liquid side. So instead of having to meter it in through the suction side, plus, if it's empty, obviously you can't add refrigerant to a system that's empty. You can add refrigerant. You can't turn the system on just if it's empty. So you don't want to run the compressor if there's no refrigerant in the system. So you're going to have to get some initial refrigerant in there, and then you may have to turn it on and add a little bit more to top it off. But you got to charge your liquid refrigerant through the liquid side, and you're going to let everything come up until either you reach your charge, which is your factory charge that's written on the side of your system. You may have to add a little bit more for longer line set length. If your tank equalizes and your system and your tank pressures are the same and you're no longer allowed to pour any in, and you're going to weigh this all out, so you're going to be able to justify it with your scales as well. So if you don't get to that, factory pressure, factory charge, whatever it is you're looking for, let's say you need 5 pounds in a system and you're not able to get to 3 in it because of your pressure's equalized, then you'll have to turn your system on. Once you turn it on, then you'll have to meter it into the low side. So system off, dump it in the liquid side. System on, meter it in the low side. So that's kind of what they're saying here in a nutshell. So with it off, you're just going to open it up and you can dump it in, and this should go in really fast, especially if it's under vacuum, because vacuum is going to pull it in really quick. So you can put a whole lot of refrigerant. You can put a few pounds in one in just a few minutes. Whereas metering it through the suction side, you've got to go really slow. So this is a good way to do it. If you can get it completely full, doing it this way, by all means, do it. But if you can't, then you can always turn it on and put the rest in through the suction. All right, so how to tell when the system is properly charged. You're going to use all the things we've learned up to this point, which are, pressures, indoor, air conditioning rules of thumb are indoor minus 30 to 35, outdoor plus 20, depending on efficiency, maybe a little higher, a little lower. You're going to want those to be in that range. You're going to want your superheat, if it's a fixed system, to be at target. You got to know how to calculate target superheat. Once you know how to calculate it, you know what you're shooting for. If it's a TXV system, you're going to have to go by subcooling. So you still want to verify superheat, but you're not going by that quite as much. And then your subcooling is going to be, usually it's around 10 degrees. And if you could get a more accurate reading, that'd be great. So your condenser split, your evaporator split, whatever, those two both have to be right. That's your two basic readings. And then superheat, subcooling has to be right. Your delta needs to be right as well, to where you have 15 to 22 degrees across. So that's going to be an indication that you're getting better performance, or that you still need to you could improve it a little bit. So even if you get a system charged good, you could maybe tweak it and make it run a little bit better, especially if you're trying to charge something and it's not that hot outside, let's say, or it's not that hot in the house. And then later on, in the summer, it's going to get really, really hot. And now you're trying to, you may not have quite enough refrigerant, or you may have too much, or whatever. You want to try to use those targets and that kind of stuff to predict not only what it's doing now, but what it's going to do in the future, so that it's going to work year round at its peak efficiency, saving them money and performing as well as it can. All right, so once the unit's properly charged and all that's in bounds, I'm not going to go through all of this because we've already talked about it. The main things you want to work on with charging: don't add it into the suction side too fast. Don't sludge your compressor. Put it in as a liquid on the liquid line when the system's off, when it's empty, and when it's on, put it in on the suction side. I'm kind of skimming through all this because this is getting into commercial refrigeration stuff. So back out of that. But I mean, that's it in a nutshell. I mean, we're going to do it in class. Obviously, there's not a ton to it. You just got to make sure that you're protecting the system. You don't want to be putting refrigerant in when you shouldn't, or where you shouldn't, or any faster than you need to. So other than that, like I said, it's not a big deal. The main thing is knowing when everything's right. So once you understand those superheat readings, subcooling readings, your basic system readings, you can get a pretty good idea as to when you're there. So as long as everything matches up, you're good. You don't need to overthink it. If you have factory charge, go by factory charge. That's like the easiest way to do it. I do want to pull up. I don't think there's anything in this slide, but if you get a brand new system, residential system, it's going to come charged with refrigerant from the factory. So let me turn this around here. I'll turn this off. Turn the camera on so you can see me. All right, so now you can see me. So you got a system that is brand new. Normally they're going to come factory charged with enough refrigerant for the indoor or outdoor unit and 15 feet of line set. If you have to go with additional line set because for whatever reason, you got a longer line set than 15 feet, which is pretty common. You got 50-foot line set, let's say. You have to calculate that additional length. Now there's a basic kind of a rule of thumb formula that you can use, which is 0.6 ounces per foot, per additional foot. So if you've got 50 feet total, the system comes charged with the unit, charge plus 15 feet of line set, then you're going to have to calculate 30 additional feet. So 35 additional feet, sorry. So let's see if I got a calculator here handy. All right, so that's going to give you 35 times 0.6. So you're looking at 21 more ounces. 21 ounces is divided by 16 ounces in a pound is 1.3 pounds. So you're looking at a pound and for 5 ounces. So that would be your additional charge. If you don't charge it for that, you're going to be undercharged even if you're at factory charge. So you've got to remember that factory charge is just telling you that, it's that plus 15 feet. And don't assume that factory charge is always in it. I mean, you want to verify. When you put in a brand new system, especially, you want to verify that it's running like it's supposed to. Don't just hook it up and forget it. If you can weigh it all in to the liquid line without turning the system on, or even with turning the system on from scratch, then obviously do that. But if you got a unit that's got refrigerant in it and you're trying to charge it on top of what's already in it, you're not going to be able to really go by factory charge because you don't know what was in it in the first place. Now, there are some cases where you're actually better off to just weigh out what's in it and weigh it back in. When we get into heat pumps, we'll talk about that method a little bit. And actually, it's sometimes it's the easiest way, because if you're doubting charge, you can weigh it out and then you don't have to worry about it. You know that charge is right. Then you can just figure out, what else is going on. So there have been times with heat pumps in the wintertime, especially, they're a little harder to check, that I've had to weigh it out just to verify that charge is right or that it's not. So once you know how to recover, it's not a big deal. Pull it out. It's not hard to do. A lot of people in the field, for whatever reason, just despise pulling charge. And I think a lot of it is because they're not comfortable with it. It's just my 2 cents worth. Bad habits and a lot of other things, but a lot of times it's because they haven't done it very much. Once you've done it a few times, it's just like the passive recovery. Once you've done it, it's not hard to do. So don't overthink it. It's just pulling refrigerant out and putting it back in. Now, there are some different ways to pull charge, and there's some different ways to recharge. This is just the basic way. So if you're doing large amounts of refrigerant, or you might have to actually use a recovery machine to push refrigerant back in. I've actually had to do that before, but that's pretty rare. So usually you can just get it to go in with tank pressure. So I will leave off from here. It's going to be the end of that, but we'll talk about the rest of it in class. So I'll see you guys next class.